Welcome back. Today we're going to be talking about the real number system. This is going to allow us to take different types of numbers and put them in an order and in a system that we can all understand so that we better know how to work with them. So let's go ahead and get started with that right now. Here we are talking about the real number system. So let's go ahead and take a look at the introduction. So before we can begin talking about the real number system, we have to talk about a few other things in order to understand what it is that we're talking about. So real numbers. Real numbers are all the values on the number line. So we're not going to be talking about any numbers that are not on the number line today. Are there numbers that are not on the number line? Yes. We call those imaginary numbers, but we're not going to be talking about them until Algebra 2. So we're going to worry about only the numbers on the number line today. Real numbers can be classified using their characteristics. Characteristics are things about the number that are going to make it stand out versus other kinds of numbers. An example of this would be for you, if I were to say that you were a boy or a girl, that would be a characteristic of your gender. Subsets. Subsets are categories of numbers with similar characteristics. So again, if I'm talking about all of the cars in the world, and then I talk about only the Fords, Fords are a subset of all of the cars that are there. The category is cars, and a subset of that is Fords. Let's take a look at a real life example for you guys. So here we are with a real life example of subsets and categories. So our real life example is going to be about Robinson. And at Robinson, there is you. Okay, so you are you, but however, there are some other things about you that not just make you a member of Robinson. At Robinson, you also have a team color. So everybody on the team will be on the red team, for example, but not every team member is going to be you. Just you is you. So inside that little circle is you by yourself, and then in a little bit bigger circle is the team that you belong to. Now, all of the teams are in the 8th grade. So everybody who's on every team is in the 8th grade. Now, granted, you are an 8th grader. You are at Robinson. You are on the red team, but you are just you. So again, inside the you category is just you by yourself. And the team color will be yourself and all of the red team members. And in the 8th grade will be all of the teams, including yourself. But the 7th graders are not in the 8th grade. So then we have the middle school. So again, every 8th grader is in the middle school. But are there people that are not in the middle school, but still at Robinson? Yes, those people are the high school students. So the high school students are still at Robinson, but they're completely separated from the middle school. So in the middle school, you can be an 8th grader, but you could also be a 7th grader. So some middle schoolers are not 8th graders. You could be on a team color that's a different team color than somebody else that's not you. So that maybe just you is you. So this is your real life example of the real number system. So now let's replace these titles with the actual titles of the real numbers and talk about what characteristics put those in their categories. Let's take a look. So here we are again with the same chart that looked like our Robinson chart, but we're going to be talking about the subsets of the real numbers. So the most basic set of numbers that we're going to talk about is the natural numbers. We're going to talk about what a natural number is in a moment. Then we have whole numbers. Again, all natural numbers are whole numbers, but not all whole numbers are natural numbers, and we'll talk about that. Then we have our integers. All of those are going to fall under the category of rational numbers, and then completely separated from the rational numbers are the irrational numbers. So a number is either going to be rational or irrational, but it can't be both. And we'll talk about why it can't be both right now. So now we're going to be talking about the natural numbers. Natural numbers are also known as the counting numbers. So when you're talking about counting numbers, you're talking about 1, 2, 3, 4, 5. Those are all the natural numbers. So some examples of those are, for example, 1, 5, 96, 1001, 4756. So these are all of the counting numbers. So if you started counting in 1 and going up, that's your natural numbers. Notice there's no decimals, there's no negatives, there's no fractions, there's no repeating decimals. All of this is natural numbers. And we write the set of natural numbers using a brace, 1, 2, 3, 4, and then 3 dots to indicate that it goes on and on and on forever and ever. We could not write the whole set of natural numbers it's infinite, and it would take us forever and infinity to write it. So we put ... to let us know that it's going on and on forever without repeating. And then we put an end brace. So if a question asks you to write the set of natural numbers, you have to include the braces. If you do not write the braces on the end, your answer will not be correct and you will not receive credit. So it is very important that you write both the braces and the numbers when talking about a set of natural numbers. Now let's take a look at whole numbers. So here we're talking about whole numbers. Whole numbers include natural numbers plus 0. So one whole number that is a natural number, I chose 8. You could pick a lot of numbers. It could be 7. It could be 4,796. A lot of numbers are natural numbers that are also whole numbers. One whole number that is not a natural number, however, is 0. And 0 is the only whole number that is not a natural number. The set of whole numbers is written again with a brace. 0, 1, 2, 3, and again with our 3 dots on and on forever and ever because it's not going to stop. We're not going to be able to finish it. And then our end brace. Remember, whenever we're writing sets that we have to have our braces there. Again, notice with whole numbers, we've got no negatives, we've got no decimals, we've got no fractions, we've got no repeating decimals. So those things are not included in whole numbers. Whole numbers are just the natural numbers plus 0. So let's go take a look now at integers. So now when talking about integers, integers are whole numbers and their opposites. So positive 5 and negative 5, those are both covered. Integers can be positive or negative. Integers, however, cannot have fractions or decimals. And the set of integers was written with, again, our braces. And we're going to put dots on the front end this time because, again, when we're now including negatives, that could go on forever infinity. So negative 3, negative 2, negative 1, 0, 1, 2, 3. And again, our dots to show it goes into infinity on the other side with our other braces. Again, the braces are very important. If you do not write them, you will not receive credit for your answer. Okay, so again, integers now include all the negative numbers and the positive numbers. However, we are not still including fractions. There are no decimals, no fractions, no decimals. Integers are only positive, negative numbers, and 0. Let's take a look now at rational numbers. Rational numbers can be written as fractions, they can be written as decimals, or they can be written as percents. So let's take a look at some examples. So example, I've got 0.66 repeating, that's a decimal. I've got 2/3, that's a fraction. 0.4, that's a terminating decimal. And 72% is a percent. Rational numbers can be written as A over B, where A and B are both integers, and we talked about what an integer is, so we know what those are, and B cannot be equal to 0. That is a very textbook-ish definition, but what it states basically is that any number that can be written as a ratio, or a fraction, is rational. And when you're writing something as a ratio, you can't have 0 as a denominator. So you don't have any fractions where 0 is the denominator. That's all that says. Yes, it sounds very wordy, but all it's saying is if you can write this number as a fraction, then it is rational, and you just can't have the bottom of that fraction be 0. So let's take a look now at our irrational numbers. Irrational numbers are numbers that can never terminate or never repeat. So let's take a look at some examples of that. So I've got 0.421 with my 3 dots on the end, stating that it is going on forever and ever. It's not repeating because I don't see my repeating bar, so that's irrational. I've got pi. If I were to type pi in my calculator and hit my button there, it would give me 3.14 with a number that goes on and on and on. Doesn't end, doesn't repeat, so it is an irrational number. I've got the square root of 2. If I put 2 in my calculator and I hit that square root button, I'm going to get 1.4 on and on and on, never terminating, never ending. So it is an irrational number. All square roots of non-perfect squares are going to be irrational numbers. So square root of 10, square root of 11. Numbers that are not perfect squares, if they become square rooted, are going to be irrational numbers. And then again, I've got a decimal there, 0.125, with the dots going on forever and ever. You know it doesn't end. You know it doesn't repeat. So it is an irrational number. Let's try some practice problems now. So here it says to classify the number practices. So we've got 24 divided by 3. We've got 3 pi, negative 6 halves, 0, and 0.66 repeating. I want you to pause the video now, try and put those numbers where you think they belong, then press play again to see if you are right. How did you do? Were you able to get all the numbers in their correct location? We're going to talk about why the numbers are in the location that they are in case you didn't understand. So let's start here with our 0.66 repeating. So my 0.66 is a decimal, so that's automatically going to make sure that it's not an integer, not a whole number, not natural. So it is repeating, so that's going to leave it in the rational category. The next number I've got there is negative 6 halves, so I'm going to have to reduce that. 6 divided by 2 is going to leave me with negative 3, and negative 3 is an integer. It doesn't have a decimal, doesn't have a fraction. It is negative, however, so that's going to leave it as an integer. 0 is the only whole number that is not anything else. It is an integer, it is rational because it is whole, however, it is not a natural number, so that's our 0 there. Then we've got 24 divided by 3. If I divide 24 divided by 3, I get 8. And I know that 8 is one of my counting numbers. That makes it a natural number. And then my last number is 3 times pi. Anytime I get pi involved, I know automatically I've got an irrational number. So if I see pi, no matter what it's multiplying to, adding to, or just pi by itself, I know it's an irrational number. So that's where it belongs. That brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in part 2.